Hi, Jerry. It's great to meet you. Do you have about 30 minutes for our conversation today?
Yeah, absolutely, I do.
Awesome. Thank you. I'm Tom Lanigan, a senior software engineer with Big O1. I'm here to guide you through this interview and assess your fit for the senior software engineer position with Joy and Grace. Are you ready to dive in?
Yeah, absolutely.
Great. Just to let you know, I'll be speaking on behalf of Joy and Grace, the consulting firm looking for the right candidate for this role. Let's get started with your experience. Can you please describe your current project and role?
Sure. I'm currently working as a backend engineer on a financial services platform built with .NET, .NET Core, C#. My role involves designing APIs, optimizing SQL Server queries, and deploying services to Azure using Azure App Services and Azure Functions.
Thanks for sharing that, Jerry. It sounds like you're working on some interesting technology. Can you walk me through the system architecture you worked on for this project?
Sure. We followed a microservices based architecture hosted in Azure. Each service is built with .NET Core, communicates via REST and Azure Service Bus, and uses SQL Server, in some cases Cosmos DB, depending on the use case.
Thank you for detailing that architecture, Jerry. It's interesting to hear how you leverage different databases based on the use case. Why did you choose those specific technologies for your project?
Cosmos DB gave us the fault tolerance and scalability that we need. That's why we chose to go with Cosmos DB for certain use cases.
Thanks for explaining that. It makes sense to use Cosmos DB for those reasons. What trade-offs or challenges did you encounter with that stack?
One challenge was managing distributed transactions across microservices. We had to use eventual consistency patterns and spend time fine-tuning performance, especially with large-scale SQL queries under load.
Thank you for sharing that challenge, Jerry. Managing distributed transactions can certainly be complex. Moving forward, how do you use dependency injection in .NET Core?
What you just saw was our AI recruiter voice assistant conducting a technical interview. It dialed the candidate at the scheduled time, held a full voice interview, and even generated an evaluation report, all without any human on the other end. It is surreal to think we live in a world where something like this is even possible. But that's the power of combining voice AI, scheduling automation, and a clean multi-agent setup. Now, if you missed part 1 of this series, I highly recommend you going back and checking it out. In that episode, we walked through the entire architecture behind the system from Calendly to VAPI, from AI agents to Supabase, and how everything connects. It will give you a solid foundation before we dive deeper in this video. So, here is what we are covering today. First, the tool choices. Why we picked PydanticAI over CrewAI to build our agents. Why APScheduler made more sense than n8n. The LLM models we chose, and how we stitched together Twilio, VAPI, and Supabase into one cohesive pipeline. Then we will dive into the AI agent design, how we structured the resume, interview, and evaluation agents, how context is passed across agents, and how we design for clarity, modularity, and full cost observability. Let's get into it. Let me take you behind the scenes, look at the tool choices I made while building this recruiter AI assistant. I want to start with PydanticAI, and this wasn't just a random pick. In a voice agent setting, especially something as complex and dynamic as a technical interview, I needed full control over the conversation flow. Not just input-output, but structured multi-turn reasoning, dynamic tool usage, and clean agent orchestration. This is where PydanticAI really shines. We are dealing with multi-agent setup here. We have a resume agent, an interview agent, and an evaluation agent. These agents need to hand off to each other seamlessly while maintaining context. With PydanticAI, I get that fine-grained control. It gives you architectural clarity while still letting you build natural and human-like conversations. And because the framework is built around type models and function-based tooling, it's incredibly composable. I could make each agent modular and focused, and the interactions felt more like orchestrating microservices than wrangling a giant prompt. Now let's talk about the LLMs powering this setup. I went with OpenAI for all the models, partly because I've worked with them extensively in the past. I've built several applications using OpenAI's models, so I'm familiar with their response patterns, quirks, and capabilities. But it wasn't just the familiarity. I also chose different models for different tasks. For voice interactions where latency is everything, I used GPT-4o Mini. It's fast, cost-effective, and holds up well in interview-style conversations. So it is the ideal model for the interview agent. But when it came time to evaluate the candidate, scorecards, reasoning through strengths and weaknesses, I switched to O4 Mini. It is slower and more expensive, sure, but for evaluation, I needed better reasoning, not real-time speed. That mix and match approach kept performance snappy where it mattered and robust where it counted. Now, you might be wondering why not use something like n8n for integrating Calendly or triggering the interviews? Great question. And the answer comes down to real world constraints. I actually used this system in production, not just a demo. I scheduled and conducted real interviews with this AI assistant. That meant I had to host the whole application in the cloud. And while n8n is great, adding another self-hosted layer just to manage a Calendly trigger felt like an overkill. Instead, I used Calendly's webhooks and handled the scheduling logic directly in Python using APScheduler. The APScheduler library is simple, lightweight, and reliable. It keeps the stack lean, fewer things to manage, fewer things to break. And in production, that simplicity mattered way more than elegance on a slide deck. I did not want 3 Docker containers and a Redis queue running just to schedule a call. All right, next up, VAPI. VAPI was an obvious choice because it supports custom LLM backends, which lets me pipe the conversation through my own PydanticAI agent rather than using some predefined models. Plus, it gives you really solid tools to control the call programmatically. Things like ending the call, muting, or handling speech detection, all from your backend. That level of control was essential when the interview agent needs to make decisions mid-call, like ending an interview early, flagging issues, or switching into a wrap-up mode. And then there is Supabase. Honestly, I love Supabase. It's basically Postgres in the cloud, with a nice API layer, auth, and persistence out of the box. We need persistence for a bunch of reasons. To score resumes and evaluation results, to track appointments, and to trigger the interviews. And importantly for APScheduler, to store job metadata, because otherwise those scheduled jobs would get wiped out if your server ever get restarted. Also, Supabase is free for the usage that we have here, so that did not hurt as well. Finally, let's talk about Twilio. VAPI does provide you with a free phone number, but there are usage limits with that free phone number. I wanted to use this assistant at scale and interview candidates internationally. So I bought a paid number from Twilio, then I imported it into VAPI. That let me handle real calls across countries and it worked seamlessly. This gave me the flexibility and production readiness I needed without adding unnecessary infrastructure complexity. In summary, every tool I picked here was selected with real-world use, simplicity, and control in mind. I did not want to build something bloated. I wanted something that worked in production with real candidates, and it did work. Let's talk about how the agents are actually designed, and more specifically, which LLM models and tools power each of them. This is a true multi-agent setup, different agents to perform different tasks. I'm using different models for different agents, and that was a deliberate choice based on how each agent needs to behave. For the resume agent, I'm using OpenAI GPT-4o. This part of the system only runs once per candidate. It's not latency sensitive, and I want really high quality output, summarization, skill extraction, and red flag detection. GPT-4o is perfect for this. It's accurate, balanced, and does a great job parsing unstructured resumes and turning them into structured insights. This agent has access to just one tool, Fetch Candidate Resume. This tool retrieves the resume from a Supabase storage. Once the resume is loaded, the agent analyzes it, and pulls out a concise summary, core skills and areas of specialization, and any flags like vague experience or unexpected gaps in employment. All of that gets returned back to the database, and now the agent has context before even starting the interview. Now, for the interview agent, latency becomes everything. This agent is interacting with the candidate in real time over a phone call. Every pause, every delay affects the user experience. So I went with OpenAI GPT-4o Mini. I actually preferred the output in responding to candidates' answers for technical questions from O4 Mini. It had slightly better reasoning and phrasing, but in testing, it was just too slow. Each response from O4 Mini took around 3 to 4 seconds. With GPT-4o Mini, I was getting sub-second latency, which made the voice interaction feel smooth and natural. That trade-off was worth it, and it made the phone-based experience feel responsive. This agent is also unique in that it does not use any tools. It is purely prompt-driven. The prompt handles greeting the candidate, asking gatekeeper questions like, are you open to work from office? Diving into projects and system design, asking technical questions, following up based on answers, and finally wrapping up the call. Every interaction is structured. We'll look into the prompt in detail when we do code walkthrough of our agents. Keeping it tool-free ensures that the call stays fast and consistent. And finally, the evaluation agent is where we take our time and do some deeper reasoning. For this, I'm using OpenAI O4 Mini. Since it runs after the call is done, using the full transcript, I don't have to worry about latency. Here, accuracy and structured thinking matters most. This agent evaluates the candidates across multiple axes: hands-on ability, system design, ownership, communication, and confidence. And it gives a final decision: recommend or not recommend. It uses a single tool, update candidate evaluation in database. This tool writes the evaluation results back to Supabase, including scores, comments, and recommendation status. So, to wrap it all up, we got 3 agents in total. Resume agent uses OpenAI GPT-4o and leverages Fetch Candidate Resume tool to fetch and parse resume. Interview agent uses GPT-4o Mini and it has no tools. And our third and final agent, evaluation agent, uses O4 Mini and it uses update candidate evaluation in database tool. As the name suggests, it updates candidate evaluation into the database. Each agent is tuned for what it needs to do. And by keeping the tools minimal and purpose specific, the whole system stays clean, testable, and easy to extend. So far, we have covered the big picture, why this voice agent exists, what problem it solves, and how the system is designed from the ground up. We talked through the pain points recruiters faced when screening candidates, how our AI assistant handles resume parsing, interviews, and evaluations. The full architecture from Calendly to VAPI to database updates, the reasoning behind the LLM models used, and how each agent is purpose-built with just the tools it needs. No fluff. This sets the stage for what's next. We will walk through the actual code, how the database models are structured, how resume parsing works, how the interview agent is prompted and tested. We will also understand how the evaluation agent does its job. It is going to be very code heavy, very real, and you will see just how powerful a few well-structured prompts can be when paired with right scaffolding. We will see how we simulate entire interviews using AI on both sides of the call. It will be very interesting. We'll automate the whole pipeline. The interview gets scheduled via Calendly. The candidate gets a real phone call from our voice agent. The call happens in real time, and everything from the resume summary to the scorecard is recorded and stored hands-free. We will cover cost calculation, deployment to render, and a full end-to-end demo. So if you're building anything with voice, LLMs, or agent orchestration, this series will give you working patterns you can adapt for your own projects. If you want this Recruiter AI voice assistant or want a voice assistant, something completely custom, we can help. Whether it's handling inbound calls, following up with leads, or automating something totally unique, we will help you figure it out. Book a free consultation call with us, and link is in the description below. Hit subscribe if you haven't already. See you in the next one.